Okay, this is the second half of 9.2. The first half was circles, and then we kind of jaunted off and did segments and sectors. This is going back to finish it off, and it is area of a regular polygon. Now, we use this term regular in first semester, and it just means that a polygon is equilateral and equiangular, which is going to help us knowing that all the sides are congruent and all the angles are congruent is going to help us. Okay, so first we're going to do parts of a regular polygon. So the center is going to be equidistant from the vertices. So your diagram's down here. So C would be the center of the figure because it's equidistant from all of the sides over here. Okay, this, the apothem, some people pronounce it apothem, some people pronounce it apothem. It's kind of whichever you prefer. The apothem is the distance from the center to a side. Now, we learned in chapter 1 that distance means go straight there. So the apothem is going to go from the center, it's going to split down the middle, and it's going to be perpendicular. That's how I know that I went straight there. So the apothem is going to be down the middle. You're going to be able to pick it out by the right arrow mark right there. Now, since this is a regular figure, the apothem actually hits at the midpoint right here. So FB would be congruent to BE as well. That's why I put the midpoint down there. A central angle of a regular polygon has its vertex at the center and its sides pass through consecutive vertices. Remember, the phrase consecutive from chapter 1 means next to. So all of these around the center are called central angles. So right here, GCH is a central angle. HC, whatever that letter is supposed to be, is a central angle. Okay, so since this is a regular pentagon, there's going to be 5 central angles over here, and they're all going to be congruent because all of these baby triangles inside this pentagon are congruent. So how I find the measure of each central angle is the formula is 360 divided by n. That's because if you drew all 5 of them in, you would notice they would touch together and they would become a circle. And we know there are 360 degrees in a circle. So, and there are 5 of these central angles. So if for this particular figure, I would do 360 divided by 5 to figure out that each of these central angles is 72. Now, if I had a hexagon, I'd do 360 divided by 6, or an octagon, I'd do 360 divided by 8. So we're going to have to do this for every problem that we have. Okay, so let's talk about area and how we find the area of these things. So to find the area of a regular n-gon with side lengths S and an apothem A divided into n congruent isosceles triangles. So instead of thinking about this figure as one pentagon, I'm going to think about it as 5 triangles because we learned last week how to find the area of a triangle, so this would be easy. The only thing you have to do is for a regular triangle that we did last week, we said 1/2 base times height. We're not going to use base and height here, but we're going to use the names that we learned on the last page. So if you think about it, instead of a base, I have a side length, so I'm going to call that S, because remember, there would be another one here, S, S, S. So we're going to call that S for side length. And then instead of height, I'm going to have apothem. So that's why I have the area of each triangle here equals 1/2 AS instead of 1/2 BH, but it's the same thing. So to put that all together, I would just need to know how many triangles there were. So in this pentagon, I would find the area of one of these triangles and I'd multiply it by 5. In a nonagon, I would find the area of one of the triangles and multiply it by 9. So that's what you have here. How many triangles do you have times the area of a triangle? Now we can clean this up a little bit because if you think about this figure here, if I have S, 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 instead of saying S times 5, I could just say, hey, why don't you find the perimeter? So that's what I did over here. The number of sides times how long each side is, that's the same thing as the perimeter of the figure. So all I did in this formula is I took N and S and I replaced it with P. Now remember, that's capital P for perimeter. So 1/2 AP is the formula that you're going to find on your formula chart. Remembering that A stands for apothem and P stands for perimeter. Okay? Alright, now the process for doing this, finding the area of a regular polygon, is kind of a long process. There's several steps to it, but the good thing is that the steps are the exact same steps every problem, so once you get it down, you're pretty good. Alright, here we go. The area of a regular heptagon. So right away, I like to keep score over on this side. That means that I have 7 sides because the heptagon means 7, and each side is 2. So that means the perimeter is 14. Now all I need to figure out to finish my figure is how long is the apothem, and then I could plug into the formula. That's what takes so much work, is figuring out the apothem. So instead of drawing a whole heptagon, I'm just going to draw one of the triangles because that's all I really care about. I know that the side is 2. What I need to know is how much is the central angle. So on the last slide, or the last page, we said the central angle was 360 divided by n. So in this case, that is 360 divided by 7. And that is 51.43 degrees. Okay, now the apothem is down the middle, so I don't even have that drawn in. So my next step is going to be, let's split this triangle in half because I'm really after the apothem, which just means splitting everything else in half. So instead of 2, now I have 1. And instead of 51.43, now I have 25.71 degrees. Now this refers us back to trig, which we just went on forever and ever. So, well, not ever and ever. How about 2 weeks? So now I can figure out this is the opposite side. This is the adjacent side. So I'm going to set up a trig function, tangent of 25.71 equals opposite over adjacent. The variable is on the bottom, so I am going to switch and divide. Okay, and then just tappy tappy. Make sure you're in degree mode. 1 divided by the tangent, it might help if I push tangent. 1 divided by the tangent of 25.71, and the apothem is 2.08. And I'm actually, you can see that it's really 2.07691 blah blah blah. So I'm going to leave that in my calculator, and I'm probably going to use the whole number instead of rounding. Okay, so recap all that work to find the apothem. You draw the triangle, find the central angle, cut the central angle and the side in half in order to locate the apothem. Set up your trig equation, which this one's tangent, switch and divide, and there's my apothem. Now that I have all of the pieces that I need for my formula, I'm just going to plug in over here where I have room. So the apothem is 2.08, the perimeter is 14, and now I'm just going to tappy that in there. So I have this 2.07, all I need to do is multiply that by 1/2 times 14. So 1/2 times 14, and then I can round because it's the very last step. So it says round to the nearest tenth. So I'm going to say that this is, I'm out of room, 15.5 feet squared. Okay, so I told you this is a lot of steps, and it is, but luckily they're the same steps every time. So I always start by locating everything I know. Side length, number of sides, and perimeter, then you're after the apothem. Central angle, 360 divided by n, gets you the central angle. Cut the side length and the angle in half. Trig function to find the apothem, and then plug it into the formula 1/2 AP, tappy tappy, and you're done. Okay, pause here and try the next two, because they're exactly the same as this, and then we'll convene back for part D. Okay, so this one's a dodecagon with side lengths of 5. So N is 12, S is 5, makes the perimeter 60. Central angle is 30, so I cut everything in half, 15 and 25. Set up my trig equation, switch and divide. So the tangent, 2.5 divided by the tangent of 15 gets me an apothem of 9.33. Plug it into your formula, 1/2 AP. 279.9 centimeters squared is your area there. Okay, part C, an octagon, so that means I have 8 sides. The side length is 4, makes the perimeter 32. Central angle is 45, cut in half would be 22.5. 4 cut in half would be 2. Be careful here, this is the part people forget. They still bring over the 4 instead of cutting in half, so don't be one of those people. Trig function, switch and divide, the apothem is 4.8, blah, blah, blah. Plug it into the formula, 1/2 AP, and there's your area, 38.6 centimeters squared. Okay. Now, why I wanted to do D together is hexagon is a little bit different. It starts out the same, so let's go for it. So a regular hexagon means I have 6 sides. The side length is also 6. So I have a perimeter of 36. So let's start with my central angle. 360 divided by 6. This has a central angle of 60, and this is why this is special, because we know this is congruent. So that means for a hexagon, those triangles are not just triangles, they're equilateral triangles. And here's where I was telling you after chapter 8, we have to know how to find the area of an equilateral triangle, because when we cut an equilateral triangle in half, now I have a 30, 60, 90 triangle. Okay, so let's put our formula on here. Across, that's A, not a 9. That looks a little confusing. Across from 30 goes x. Across from 60, x on the square root of 3. Across from 90 is 2x. All I'm after is the apothem. So if x is equal to 3, then the apothem is 3 on the square root of 3. And we talked about this in chapter 5. The height, or in this case the apothem, is always half on the square root of 3, and that's why. I took the side length, I cut it in half, and then the formula said to put it on the square root of 3. So half on the square root of 3. Hexagon should be the easiest thing for you once you get used to it, because you can just read the problem. Oh, it's a hexagon, side length of 6. Oh, the apothem is half on the square root of 3, and you can do it without all of the steps, but you have to get good at it first. Okay, so now I'm ready to plug into my formula. 1/2 apothem perimeter. The problem with these other ones is that I had to use trig, so I had to round, so my answers weren't exact. But with a hexagon, I didn't have to use trig, so I didn't have to round. So I'm going to use an exact answer, which just basically means type everything in, 1/2 times 3 times 36. Just skip typing in the square root of 3. That is 54. And then bring back down your square root of 3. Okay, 1/2 times 3 times 36 is 54 on the square root of 3. So hexagons are special because you have a square root in your answer instead of trig, so no decimals allowed. Expect to see a hexagon on the quiz and the test, at least one. Okay, last one. Find the area of a regular octagon with an apothem length of 8. So here's why this one's different. They gave us the apothem. We have to find the side length. So I know that there are 8 sides. I don't know what the side length is, so I can't figure out what the perimeter is either, but I do know the apothem is 8. So we're going to start the problem like a normal one. I don't know what this is, but I'm still going to find my central angle is 45. So when I cut this in half, now what you have to remember, is that if this is S, this is cut in half. And I know I just messed that up. But make sure you remember that that's half, not the whole thing. Otherwise, your answer will be half of what it should be. The apothem, I know, is 8. This is 22.5. You are going to set up the same trig equation, only you're going to be solving for a different thing. Because I want to find the opposite, and I have the adjacent. So it's still going to be tangent. Now I don't know the opposite, but I do know the adjacent. So all that happened here was the variable is in a different place, but it's still tangent. It's still the same story. Times 8. I'm going to multiply this time to find my answer. So this tells me my answer. This piece right here is 3.31. Here's where people get stuck, is that sometimes now people will jump automatically and say, oh, the side length is 3.31. But remember, we're not done yet. That is, I had to cut the triangle in half. So if this is 3.31, I still have to multiply it by 2 to get back to the real side length is 6.63. If you forget this multiply by 2 step, you're going to be half off. So make yourself a note in the margin not to do that. So the side length is 6.63. There are 8 sides, so that means the perimeter is 53.02. And now we can plug into our formula. 1/2 AP. The apothem is 8. The perimeter is 53.02. Why didn't I put apothem in there? How about that? So 4 times that perimeter. And your answer is 212.1 millimeters squared. Okay, so this one's a little different. Go back and look at it if you didn't quite get it. We have to find the side length instead of the apothem. So that just flips your trig function. That gives you half the side length. You have to double it to get the full thing, and then multiply by n to get your perimeter before you're ready. So same kind of process, just a little bit coming at it from a different angle. Okay, see you tomorrow.